Okay, who are strong nucleophiles? Two factors, negative charge and polarizability or size, right? Third period or down. So if you look at the structure of this guy, you should rule out that, you should pinpoint that the one that is strong nucleophile. Look at the charge first. Who has a negative charge? This guy has a negative charge, right? So this is a strong nucleophile. Don't even think about it. All right. Now the rest, the one that doesn't have charge, you have to look at the polarizability to help out. All right. So again, one more time, polarizability. The size of atom have to be big enough to be polarizable. Third period, fourth, fifth, or below. Those are strong nucleophile. Even without a charge. Second period need a charge. They're not polarizable enough. And the first period, don't even talk about it. Never. Hydride never attack carbon. All right. So who's big enough to become polarizable? Sulfide, phosphide, right there. This is phosphine, pH 3. All right. So these are strong nucleophile. The rest are weak nucleophile. All right. One more question: is third butoxide got a negative charge a strong nucleophile compared to hydroxide and methoxide? Okay. Third butoxide is actually it's a strong reagent, a strong base, but not strong nucleophile. And here's the reason why. All right, I'll give you an answer right away. So because you're going to use a lot of third butoxide as a base, as a good base, and it's not a nucleophile. Anyway, so let's say if I have all of them do nucleophilic attack in SN2, okay, pass through that transition state. All right. So we have an OH bond to that carbon. This is propyl group right here. Methoxy group bond to that carbon. There's a propyl group, and third butoxy group bonded to that carbon, and that's a propyl group. All right, I'm going to show you a full structure here. Propyl group show all carbon, show all hydrogen. Methyl, third butyl group show all carbon, hydrogen. All right, you're going to see that down here is really packed down here. Something unstable right here. Okay. All right, look at the smallest one. OH, hydrogen is small, oxygen is small. So this guy relatively more stable than down here. At down here, when the group on oxygen is bigger, it got higher steric hindrance. Third butoxide is even higher steric hindrance, which means that the transition state right here is really unstable. The transition state right here is less stable than the transition state of just hydroxide, because this guy's small. They can be anywhere. But this guy need more space. But this guy, the alkyl halide doesn't have a lot of space because it's just already packed, already big, right? Third butoxide, you don't even talk about it. This is way too big. The alkyl halide is really packed down here. Okay, additional steric hindrance there. If you look at the energy diagram of the SN2 reaction, real high. This guy, the transition state of the third butoxide attack is not as stable at all. High activation energy. That's the reason why third butoxide is one of the worst nucleophile. But it's a strong base. We talk about the base in a bit, right? But this guy is one of the worst nucleophile. And that's a good thing for us. So we can use third butoxide as a base, and we don't have to worry about you get a substitution product. This guy going to go elimination. All right. So third butoxide looks like it's a strong reagent, but it's only strong base, not a strong nucleophile. It's a weak nucleophile. Activation energy for SN2 is too high. Okay. All right. Let's go to the basic.